Hi, I'm Matthew Joslin, and I'm from the University of Texas at Dallas. Today I'll be presenting my paper, Measuring and Analyzing Search Engine Poisoning of Linguistic Collisions. This is joint work with my advisor, Shuang Hao, and our collaborators, Nung Li and Haojin Zhu from Shanghai Jiaotong University, and Minhui Shui from Macquarie University. So search is very important to the web. When a user wants to find a page, even one that they've visited before, they often won't enter the URL or domain name. Instead, they often use a search engine to search for the keyword. For example, if you've needed to find the S&P conference program over the past 3 days, you probably just searched for the keyword. In fact, most of us probably can't remember the URL. Not surprisingly, a majority of web traffic comes from search, and up to 90% of users stop searching after the first page. Websites know that search is important, so they carefully optimize their sites to remain on the first page of results. As a result, the ranking on the first page of results is very difficult for popular terms. Users also make spelling mistakes when typing in their searches. For instance, if a user wants to search for Adobe and they accidentally swap the last 2 characters, they may actually search for a misspelling. Adversaries have known for a long time that this is a problem, and so they've targeted misspellings in search engine optimization. For instance, Snickers targeted a variety of misspellings in their search ad campaign, "You're not you when you're hungry." And Amazon was recently ordered to stop typo targeting misspellings of Birkenstocks, a German shoe retailer. To help improve the user experience and to protect users from typos, the search engines have introduced autocorrection and auto-suggestion defenses. These defenses help improve the user experience, and they warn the user that their search query may be misspelled. They may even edit the search results if they have high confidence. So for instance, if a user searches for Adobe and they accidentally swap the last 2 characters, the search engine has high confidence that they actually meant to search for the company name Adobe. And so they change all of the search results to be for Adobe. Similarly, if a user searches for Adobe by appending a C to the word Adobe, and the search engine has medium confidence that they meant to search for Adobe, they may only change the first result in Adobe and only warn the user that the search query may be misspelled. Finally, if a user misspells Adobe by replacing an O with a U, and the search engine has low confidence, they may not change any of the results and instead ask the user, "Did you mean Adobe?" All of these different types of defenses offer some sort of protection to the user. Either they warn the user or they even change the user's search results. These defenses seem to be effective as we observed spammers on underground forums complaining that these defenses have made misspelling SEO much more difficult. To avoid these automated corrections by search engines, attackers can employ a new type of attack, which we term linguistic collision misspellings. These misspellings can avoid automated defenses because they coincide with existing words, even in other languages. For instance, if a user searches for Cialis and deletes the A, they may actually search for Silas, which the search engine won't autocorrect. This is because Silas is an existing word in the Esperanto language meaning chilies. However, the search user will not be shown results that were related to chilies. Instead, they'll be shown a variety of different URLs that are advertising Cialis. In fact, they may even see advertisements that were purchased by advertisers to promote Cialis. Or they may see illicit pharmaceutical websites which manage to achieve high rank for this search. To understand how widespread linguistic collisions are, we analyzed the 2 most popular languages on the internet, English and Chinese. For English, we looked at the Google search engine, which has the highest market share, and we looked at the Baidu search engine, which is the most popular search engine for Chinese speakers. We also looked at, to understand how prevalent these attacker activity is across different types of keywords, we looked at the Alexa 10K names and we checked for English. And then we also wanted to understand what types of keywords attackers may target. So we looked at 13 different categories for English and Chinese. So in English, we looked at English and Chinese, we looked at 4 different spam-related categories: the drugs, adult, and gambling, and software. So these are typical targets for spammers that we thought they may continue to target in linguistic collision attacks. So for instance, in English, we looked at Cialis, the popular drug, and poker, a gambling game. And in Chinese, we looked at dama, which means marijuana, and mahjong, the popular gambling game. We also looked at 9 other types of categories, which include popular product names and brand names, because we believe these terms could also be targeted by attackers, similar to what Amazon did. So now that we have our set of target keywords, we can look at generating the misspellings using a variety of different processes for both languages. Once we have the misspellings, we can check on the search engines to see which terms will not be auto-corrected and avoid the defenses. And finally, after we know which search results are not auto-corrected, we can check on a public blacklist to see which ones are poisoned. So for English, it's relatively straightforward to generate misspellings. We can use the Demerol-Levenstein edit distance 1 operations. These allow us to insert a character, replace a character, transpose 2 characters, or delete a character. So in particular, we limited the replacement operations to the adjacent keys on a QWERTY keyboard. We also looked at the vowel replacement operations because we believe users may accidentally misspell the word. And these words also have a higher chance of still being existing words in another language. So for Chinese, so brute force checking all of these different generated misspellings is a bit time consuming. We don't want to check all of the Alexa 10K generated misspellings, as that's going to require a lot of different searches. And although you might expect that we could just check dictionaries, these dictionaries have poor coverage for things like slang, product terms, and some languages have poor coverage just in general. So we introduce a character-level recurrent neural network to predict which misspellings will not be auto-corrected by the search engine. We train this network with existing words and dictionaries, and then we are able to predict the probability distribution of the next character in a sequence of characters. So for Chinese, the situation is a bit different. Chinese users use Pinyin input as a main method for searching on Baidu. The Pinyin input method allows users to type Chinese words using the English alphabet. So we can use the Demerol-Levenstein edit distance 1 operations that we mentioned previously. However, we can also use some more interesting properties of Chinese to generate other types of misspellings. For instance, the same Pinyin can map to different words, and different tones can map to different characters. For instance, mahjong, with the same pronunciation, can either mean a tile-based game or sesame sauce. We can also look at the fuzzy Pinyin. Because there's multiple dialects in Chinese, some users may not be able to distinguish similar sounding sounds. And so fuzzy Pinyin allows these users to enter similar sounding consonants and vowels interchangeably. So we use these substitutions to generate other types of misspellings. Because the Pinyin input method requires that a misspelled Chinese word still be an existing Chinese word, for the Chinese data set, we can simply check to see whether it is in a Chinese dictionary. So now that we have our set of input misspelled keywords, we're going to check on Google and Baidu to see which terms will not be auto-corrected. After we know which ones are not auto-corrected, we can check across VirusTotal to see which ones are blacklisted. We also check to see the search volumes and the device types of users who are searching for these terms on Google AdWords and Baidu Index. And finally, to understand why search engines may fail to autocorrect English searches, we checked using Google Translate to see what languages they are identified as. So overall, we collected just under 1.8 million misspelling keywords. And we found that for misspellings which aren't auto-corrected by search engines, that is linguistic collision misspellings, just under 1.2% have search results that are poisoned on the first page. So for English, we can look at the different categories here on the x-axis. We have the four spammer perennial favorites on the left, and we also have the 9 product terms on the right. And on the y-axis, you can see the percentage of searches which were poisoned. We also have 5 different cases here, the original search term, and then 3 types of autocorrection defenses. And finally, we have the non-autocorrected case. That is the linguistic collision misspellings, which are not protected at all. The users are not warned. So you can see that some of these perennial favorites, the drugs, adult, and gambling categories, are targeted at over 4 times the rate of others. Similarly, for Chinese, we can see that these perennial favorites are again targeted in Chinese. However, it's interesting to note that overall, the autocorrected cases exhibit a lower overall poisoning rate than English. Finally, for Alexa, we checked the 1K domain names exhaustively so that we could compare with our RNN-based results. We found that the RNN is 2.8 times more efficient than randomly sampling the misspellings we generate using the processes described earlier. We also checked the Alexa 10K names using the RNN, and we found that attackers do exhibit activity across the long tail of domains. And this makes us think that this is quite a common technique. We also examined what types of devices users are using when they search for these words. For English, we got this data from Google AdWords, and for Chinese, we used Baidu Index. So you can see here that we have both the original keywords and the misspellings that were poisoned by attackers. And you can see that for the original keywords, desktop has a higher user percentage, while the misspellings that attackers target have a higher mobile number. This may be due to the fact that the mobile users can more likely make misspelling mistakes on small screens. So we also looked at the top domains in English that contributed to these poisonings. We found that the top traffic monetization is malvertising. And we also saw that there's a wide range of different domains here. Some are poisoning a large number of searches and using a wide variety of URLs. And you can notice here, too, that the zero catch and @space domains are using third-level domains. This means that they're actually free hosting sites that the attackers are using to host their infrastructure and avoid paying for their attacks. Also note that one of the names is censored, and we can check the paper for the real domain. And finally, we also checked the languages as identified by Google Translate, and we found that English is the primary language that we're seeing linguistic collisions with, from English to English, that is. And you can also see that drugs has a lower overall English percentage. We think this may be due to the fact that most of the inputs in the drugs category use more scientific or chemistry-based names. And so the Google Translate may detect them as being something other than English. And finally, there's also a long tail of different languages here. We found 74 different languages with collisions. So, in conclusion, we conducted the first investigation into linguistic collisions for English and Chinese, and we found that 1.2% of linguistic collision misspellings, that is, misspellings which are not autocorrected, have poisoned search results on the first page. We also found that certain categories are more heavily targeted, and mobile users are more likely to search for poisoned terms. Thank you for your attention. I'm happy to take any questions now.
Thanks, Matthew. We have time for a few questions. Luc Desitels from Samsung Research America. Maybe this is in the paper, but it didn't come up in the presentation. Have you had any response from Google or Baidu? Seems like their responsibility that if I search for peppers, I should see things about peppers.
Yeah. This is kind of a difficult problem for the search engines to solve because users may actually be intending to search for these in some cases, and it's not exactly obvious that you can cleanly define which terms are, actually misspellings and which terms are actually, what the user's meant to search for. So, no.
Ellie Cannell, Carnegie Mellon University Software Engineering Institute. I'm kind of surprised by that one result you showed where the Chinese results were at a much lower base rate of infection. I'm curious if you have any insight into why that might be.
Yeah, so that seems to be, I should have mentioned in the talk, but we found that basically Baidu seems to heavily prefer reputed domains. So we saw that the same 1,000 domains actually occurred for about 93% of the search listings in the non-auto-corrected case, or in the auto-corrected cases. Yeah.
Does that mean the poisoned ones would be farther down the search results, or they're just simply not present?
No, so they're still ranking in the first result about as often as the other domains. They're just, if I understand your question correctly, they are still showing up, and they're not, those searches aren't as competitive. So those misspellings aren't as competitive, yeah.
Thank you.
Great question from the back, please.
Yep. So my name is Tina. I'm from the Federal Trade Commission. My question is, I noticed you were looking primarily at organic search results. Do you bother looking into the ads that show up during searches as well?
That's a great question, yes. We plan on doing that in our future work.
And then my second quick question is, in terms of the range of the malicious URLs, did you notice that they're primarily in the .com? If they're trying to particularly take advantage of brand names? Or do you notice that they were taking advantage of different GTLDs as well?
I think we should take that offline. Yeah.
Thank you very much.
Yeah,
Sorry.
thank you.
Yeah, just Bhavani Thuraisingam from University of Texas, Dallas. It's a very interesting paper. So my question is, what is the ultimate goal of the attacker, right?
Yeah.
Yes, could you sort of elaborate on that a bit?
Yeah, so they want to promote these poisoned URLs, right?
Yeah.
It's really difficult if you want to rank for the first result on Google, but it's much easier if you want to rank for a misspelling of Google. And I think some other types of delivering spam have gotten less easy to conduct. For instance, I don't open all of my email, and most of it just gets filtered by Google Mail. So this is a pretty easy way, low-cost way, low-risk way to promote, yeah.
Okay, thank you.
Thank you. Let's thank the speaker one more time.